Hey, what's up, you guys? It's Grayson.
And Christine.
And this is Green Physics 101.
On today's episode of Green Physics 101, we're going to be discussing why sunsets look the way they do.
Basically, just why they look red and magenta. Basically, just why they don't look blue. Sunsets occur through a phenomenon I like to call scattering. So, Christine, elaborate on scattering.
Scattering occurs when light emitted from the sun hits particles and molecules in Earth's atmosphere, causing the light to be diverging into other directions, causing the color that we see in sunsets. As Earth rotates upon its tilted axis, the sun hits the Earth at different angles, causing different wavelengths to occur, making this colors that we see in sunsets. And since red is the longest wavelength in the visible light spectrum, you see that as the sun hits the Earth and goes below the horizon, causing the longest wavelength of red to occur.
And most of you may be wondering why we only see the warmer colors. What happens to blue? What happens to green? What happens to violet? Upon hitting the atmosphere at that certain angle during the evening, they pretty much just scatter throughout the atmosphere, so they aren't seen. Blue is sometimes seen, but it's mainly overtaken by red and magenta and yellow and all those sorts of colors.
And that's why we see blue during the daytime, because it fills our atmosphere, causing the sky to be blue most of the time.
On the full electromagnetic spectrum, from radio waves all the way to gamma rays, there's the visible light spectrum. There's a little tiny sliver of rays that we see called the visible light waves, and Christine over here is going to explain what those are.
Visible light is the only thing that the human eye can see, and it has all the colors of the rainbow, Roy G. Biv. Right before visible light, you have infrared waves, and infrared literally means before red. And red is the longest wavelength in the visible light spectrum. After the visible light spectrum, you have ultraviolet, which means after violet.
Blue and violet have shorter wavelengths, which means they interact more and slow down while they enter the atmosphere, while red has a longer wavelength, which means it interacts less and spreads across the atmosphere, which is why we have this beautiful sunset that you're witnessing right now. Look how pretty.
That's all for this episode of Green Physics 101. And remember, if it don't scatter, it don't matter.
Right before you stop. I'm in my Tesla.
As you can see in the
Oh no, there's the spectrum. No.
What?
You how you are, you just have to say that you're fine when you're not really fine, but you just can't get into it because they would never understand.
You got it. Earth is tilted on its axis while it's tilted on its axis. During the evening, it rotates and rotates. It's spinning, it's stirring. Wavelengths from red and orange and yellow shine down on the Earth through the atmosphere, while blue, purple, green, they scatter in the atmosphere. But red and orange and yellow, they reach the surface while it's sunsetting. That's why we see red, orange, magenta. Magenta? I'm not really freaking sure. And that's why sunsets occur.
What are your intentions with my toes?
Make good choices.